Hey everybody, good to kind of see you guys again, or at least you seeing me. I'm looking out at a sea of empty desks, so I miss you guys. Hopefully everything's going good at home. What we're gonna do is I'm gonna give you guys the guided notes all filled out. Mine looks blank right now, don't worry, yours will be filled out. And then I'll give you guys those. You guys can copy them, and I'll kind of just key a few problems. Hopefully this will help you follow the rest of them. But again, please make sure that you actually are writing down all this stuff, watching this video a couple of times. Maybe it doesn't sink in the first time. You can just watch right now because again, you have all of it written down for you in Google Classroom. All right, so I'm gonna give you guys my version of notes, the keys, so you can really pay attention and see if it makes sense. And then again, try your independent practice. We're not really gonna call it homework as much. We're just gonna say that when you learn something, you gotta practice it or you can't get better. So make sure you're actually giving full effort here. All right, so numbers 1, 2, and 6 is what we're gonna focus on today. Now, the thing about this is we're gonna learn how to solve these problems, and it can't be done by kind of like regular math, all by plus or minus or times or divide, like we've solved the equations in the past. So whenever you have a letter squared and a single letter in the same problem, you wanna solve by factoring. So we're gonna try to use the zero product rule, but the big deal is one side has to be 0. Today, all your problems will be 0 that we give you. Tomorrow, we'll make it a little bit more challenging. And it might not be tomorrow, in a couple days. All right, so whenever we look at this problem, 0, well, we learned the zero product rule. It's only a rule if 0 is the product or the answer to a times problem. Well, this isn't a times problem. So we have to do our factoring process to turn it into a times problem. And we have to know which method to use. Now, at first we'll kind of tell you the methods, but then you're trying to work towards a little bit of independence. This, we will use ooh, that's a marker that doesn't work. We will use MA bottoms up. That looks like all your problems from 7.4b. Remember, the early parts of your notes are really gonna help you guys out in these later sections in chapter 7. So when I do this, I can write my M number, my A number. My M is the front 1 times -20, and the add number is +8. Well, what two special numbers multiply together to be -20 and add together to be +8? You can pause it right now, think about it. And the correct answers are -2 and +10. They add together to be +8, they multiply together to be -20. That was the hardest step for most kids. After you get your special numbers, you go ahead and you set up 2 parentheses. They both start with the letter C instead of letter X. The actual letter doesn't cause an issue. And then we put our special number -2, special number +10. But the big deal is this, you gotta remember that that was all kind of like scratch work. It still equals 0. Now, we've never seen that before where we factored an equal 0, but you cannot drop the equal sign, you can't drop the right side. Now, we still have to divide by the front number, but divide by 1 keeps it -2. Divide by 1 keeps it 10. So I have parentheses C -2 times parentheses C +10 equals 0. Again, I cannot drop the equal 0. And we realized we can do our zero product rule. For the last couple of days, we practiced when a times problem equals 0, front equals 0, back equals 0. So you guys, I look at it, C -2 is the front or the first factor, C +10 is the back or the second factor, and I go right here, front equals 0, back equals 0. When I add 2 to both sides, +2 is my final answer. When I -10 on both sides, -10 is my final answer. All right, let's look at number 2. So number 2, again, is not a times problem equals 0 yet. And I want to turn it into a times problem, and that's the word factor. So we're going to solve by factoring. So the first method is, or we have to figure out the method is, does that look like a GCF, an MA bottoms up, or a DOS problem? You can pause if you don't want to hear the answer. But it's a GCF problem. They have something in common, and it's a 2-step process. You look at the numbers. 1 and 2 do not have a greatest common factor, but x squared and x have a greatest common factor of x. Now I gotta times it by its leftovers. And when I divide x squared by x, I'm left over with x, minus, when I take 2x divided by x, I'm left over with 2. Again, that is section 7.3, factoring by GCF. But I can't forget that I now have an equation. It equals 0. I can't drop that. And now this is the zero product rule. I can go front equals 0, back equals 0. Remember, math people say set each factor equal to 0. So the factor of x can equal 0. The factor of x minus 2 can equal 0, and we solve them separately. This x is already by itself, but I have to add 2 on both sides to solve that one. Okay, our final example in our video, but again, you guys have 6 total in your notes, is number 6. And you guys, you would think about what type of factoring we should use. Well, this problem to me doesn't look like a greatest common factor problem. 25 and 16 don't have a GCF. A squared and no a's at all don't have a GCF. It definitely doesn't look like an MA bottoms up problem because there's not 3 pieces or a trinomial. So the only way I could probably do this is difference of squares, section 7.5. So I circle the minus sign, I fork the front, and I fork the back. To break up the 25a squared, it's 5a times 5a. To break up the 16, it's 4 times 4. And now I set up my 2 factors or my 2 parentheses. So, front fork goes in the front. Back fork goes in the back. And you gotta put 1 plus, 1 minus as our rule. But I cannot forget, it equals 0. Earlier on in these sections, and early in chapter 7, we didn't have the equal 0 part and we would have been done. We turned it into a times problem. But now we have a times problem equals 0, and that's the zero product rule. So we can do my little melody of front equals 0, back equals 0. And when we do that, we're gonna see that we can write our answer just a little bit different in this special case. I'm gonna say the math out loud. Minus 4 on each side. 5a equals negative 4. Divide by 5 on both sides. A is equal to negative 4 over 5. Now you can box that, because you're done. Here, we'll add 4 on both sides. 5a is equal to positive 4. Divide both sides by 5. A is equal to positive 4 over 5, and you could box that. But math people have a nice little way to write this answer when you have the same number, but one of them is positive and one of them is negative. Now you can leave it like that, but if you want to try to learn this, you guys can condense your answer or make a single answer, even though it is 2 answers, of plus or minus 4/5. And math people use that symbol to say positive and negative. Your answer for, oh sorry, that's letter A, not X. Your answer for A could be positive 4 over 5 or negative 4 over 5. It's just a shorter way of writing those 2 answers. All right, you guys, I hope this helps you guys follow along with your 7.7 notes. Try the independent practice. There is no way that you're gonna get better without doing that. Also, again, rewatch the videos. I don't know how many times I can say that, but if you watch things a couple of times, it will start to click, and then apply it to your independent practice. It's your boy, Mr. P. Miss you guys. Stay healthy, stay safe, and hopefully we get to come back here sometime soon and see each other. All right, bye.